Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Students, in this video we'll discuss question number 38 of NEET physics paper 2016. Students, let us solve question number 38. It says a body of mass 1 kilogram begins to move under the action of a time dependent force. There is a block of mass 1 kilogram. It begins to move means its initial velocity is 0. Its motion is starting from rest, and the force that is applied is 2t I cap plus 3t square j cap Newton. So this is a variable force, is a function of time. As you can see here, as time increases, force will also increase. So this is not a constant force. At time t equals to 0, the force is 0. That means if the force is 0, then I would say that initial velocity is not 0, because initial velocity, if it is 0 and force is also 0, the body will never move. So it means that u is not 0. Starting its motion means already it is in motion, and might be some at a certain time a force starts acting. So, or it starts from 0, as it is also possible that the body is having initial velocity 0. At time t equals to 0, the force is 0, but when the time increases to say 1 second, the force will be 2, 3 plus 2, 3 Newton. So immediately as the force is applied, then the body will not move. As the time increases, obviously the force is there and the body starts moving. And when I cap and j cap are unit vectors along x and y axis, that is known to us, what power will be developed by the force at the time t? This time is any time t. So our aim is to find power as a function of time t, or power at any time t. This t is any time t, any generic time t. Now, for instantaneous power or power developed at that particular instant, we know that power is work done upon time taken to do the work, and work done is the dot product of force and displacement. It's the dot product of force and displacement divided by time t. This t can be associated with s or can be associated with f. Because if I associate with f, then it will not have any meaning. So I will associate with displacement. That will become f dot product s over t. This is basically the velocity vector. So this will become f dot v, velocity vector. So this power, instantaneous power, is basically the dot product of the force and the velocity vector. I have the force vector, which is given by this equation in SI system. I want the velocity vector, and then I'll find the dot product. The velocity vector can be obtained from force equation as follows. You will take the force equation. Just let me write down the force equation. The force was 2t I cap plus 3t square j cap. This was the force vector, and from this we want velocity vector, because this is the only information given. So how to find force from velocity from force? Force is mass into acceleration, and this is 2t I cap plus 3t square j cap. If I put the value of A, m, which is 1 kilogram given in the question, mass is 1 kilogram, then this is 1. So acceleration is this one. Acceleration is dv over dt. This is dv over dt, which is given by 2t I cap plus 3t square j cap. This is your acceleration, the rate of change of velocity, because A is dv over dt, the change in velocity over the time taken for the change. So from here I write dv vector equals to 2t I cap plus 3t square j cap into dt. If I take integration on both sides of the equation, then dv integration equals to 2t, this dt is also taken inside, dt I cap plus 3t square dt j cap integration on both sides of the equations. From here I'll get the velocity vector, this one I'll get the velocity vector v, because initially the velocity was 0, starting from 0, u equals to 0 to u or v equals to some final velocity v. So this is the v corresponding to time t. When initially time was 0, velocity was 0. When time is equal to some any time t, the velocity is v. So we want this velocity when the time is t. So here the limit will be from t equals to 0 to t equals to t. This will give only v. That will give 2 comes out. This is t dt integration, that is t square over 2. So 2t dt, 2 will come out, and t square, this will become t square by 2, t2 and that 2 will cancel, so I'll write that t square by 2, I cap is there, and this varies from 0 to t, and I cap is there, plus 3 comes out, this is t square dt, integration will be t raised to the power 3 divided by 3, this varies from 0 to t, and j cap is there. So from here I will write v vector as this 2 and this 2 will cancel, this 3 and this 3 will cancel. This if I put here, this is t square minus 0, that is t square I cap. So this is t square I cap, and this will be t to the power 3 j cap plus t to the power 3 j cap. So this is the velocity vector I'm getting in meter per second. As a unit, and the force vector I already had earlier, that is 2t I cap plus 3t square j cap Newton, that is kilogram meter per second. That is Newton, this is Newton meter per second square. So this is Newton, and this is velocity meter per second. Now the power is, sorry, this is a scalar quantity, this is scalar, the instantaneous power equals to the dot product of f dot b. The outcome of any dot product is always a scalar quantity, this power is a scalar quantity, f dot b. So f is here, that is 2t I cap plus 3t square j cap, dot product of t square I cap plus tq j cap. We can use the direct method, that only you can multiply the coefficients of I and the coefficients of j and then add up. If I do that, this is 2t, this is t square, so this will become, so we know that if a vector A is a1 x I cap plus a2 x j cap, I will not write the third term. B vector is b1 x cap plus b2 y j cap. This is y actually, a1x, a2y, and so on. Then the dot product is only you write the coefficient. This is actually x is not required. Just let me explain this first here. Then I'll just do. Otherwise, let me solve this first. So just multiply the corresponding terms containing j and j. J with j, this will be this one. So the answer is this into this. This is 2tq, and plus this into this, that is 3t to the power 5. Okay, so this is in watt. Power unit is watt. So this is the answer, that is 2tq plus 3t5. 2tq plus 3t to the power 5. So option number 1 is correct. Now how this is done, that how I multiply these two and add them, that we'll see here. So let us take one example. We know that if a vector A is given by a1 I cap or a2 j cap and a3 k cap, and another vector B is given by b1 I cap plus b2 j cap plus b3 k cap, then we know that if you have the dot product, then we'll have these two quantities a1 b1 are multiplied. Similarly this and this, a2 b2, similarly this one and this one, a3 and b3, these are multiplied and then added up. So a dot b is always this one. Okay, that you might have done in your classes. Now you can just directly apply the formula. Otherwise you can go for simple calculations. Suppose I'm just going for, if you don't know this, then you can go for normal dot product. So let us go for normal dot product and see whether I'm getting this or not. So this f is f dot b, f is 2t I cap plus 3t square j cap, dot product of t square I cap plus 3t. B is how much I'm getting, t square plus tq. This is tq j cap. So let us find the dot product. So this is 2t I cap, this one, dot product of the whole thing, that is t square I cap plus tq j cap, plus this one, that is 3t square j cap, dot product of the whole thing, dot product whole thing. What is that? T square I cap plus tq j cap. Just as we multiply numbers, this dot product of the whole thing plus this dot product of the whole thing. Now this I will open the bracket. This dot product will go to this one and also this one. So 2t I cap dot t square I cap, 2t, and dot product of this one, that is 2tq, this is 2t and t square, 2tq I dot I. Similarly this and this will give me 2t to the power 4, 2t and tq, 2t to the power 4 I dot j, I dot j. This one will give me plus 3t square and t square, 3 to the power 4 j dot I, j dot I, plus this and this, that is 3 t to the power 5 j dot j. We know that I dot j, so we know that I dot I is 1, I dot I is 1, I dot j, because dot product is I a dot b is ab cos theta, so I dot j is I j cos theta. Cos theta is 90 because I and j are perpendicular to each other. I is in this direction and j in y direction. So cos 90 is 0. So I dot j is 0 and j dot I is also 0. This becomes 1 and this becomes 1. If that is the case, then what is left is 2tq. So f dot v finally is left with 2tq. This factor will be there and this factor will be there. That is 3t to the power 5 plus 3t to the power 5. And exactly what we got here also. You can see we got also 3t square plus 3t to the power 5 what. So this way you can solve, but to save your time you must know that you can directly multiply the coefficients, corresponding coefficients, that is x component, y component and z component, and then add them up. Okay, so this is the answer. Thank you.